All right, sigma notation. What the heck is it? Now you probably won't recognize the word sigma. That's because no one ever writes it down. This thing right here, this big nasty E looking thing, is the letter sigma in what I figure is probably the Greek alphabet. Now, all it means is add some stuff up. So this is really just a really fancy way of giving you a sequence problem, either in arithmetic or geometric sequence, or maybe neither, but usually one of those two. And it's just a really fancy sort of math symbol kind of way of asking you questions, just like you would have seen in the previous videos about different types of series. And this is a series because they're asking you to add the terms up. So as you go from term 1 to term 5 and plug in all these different n's, you're going to be adding them up. But so ultimately, this will result in a single number, which is the sum of all the terms given. So what's the sigma mean? Well, basically, we're just going to go from this number to this number one at a time, plugging in here. So, for example, this one, we'd start at 1, plug in 1 for n, then we'd plug in 2 for n, then 3 for n, then 4 for n, and then 5 for n would be the last one. And since we'd see that 5 is up here, that's like, oh, we do 5, and that's our last one. Let's take a look at a few examples that aren't really quite that sequency. They're just, all right, so this one we're going to go from 1 to 4. So we'll start at 1. We just plug in 1 for k. So there's going to be 7 times 1 plus 6. This is our first term. Now that I've plugged in 1, I'm going to plug in 2. So what happens when I plug in 2? Well, I plug in 2 for k, so I get 7 times 2 plus 6. Now I'm going to plug in 3 for k. 7 times 3 plus 6. And I'm just underlining them to make it more obvious to you where each term starts and stops. Plug in 4 and we get 7 times 4 plus 6. Now you notice there's a plus 6 in each one. So even though k is making this first term get bigger and bigger, like that 7 plus 6, since 14 plus 6, I keep adding 7 to that first term, but the 6 just keeps staying there, and that's because there's no k in the 6. So every time I add another term, I'm adding another 6. So I could add all this up, I get a number. What you'll notice is that these terms, let's see, this one is 13, then we got 20, then we got 27, then we got 30, what the heck, oh, 34. So you can see that we're actually just adding 7 each time. Add 7, add 7, add 7. It's not a coincidence that this number is right here. Turns out the way you spot an arithmetic sequence is that it's a number times the k or the n or whatever letter they're using. And it's going to turn out that your common difference is that coefficient of the k or the n or whatever. Oops, look at this one. I seem to have messed up. You need the letters to match. So this should have been an n. You'll never see one where they deliberately make the letters different. So what's happening on this, we got factorials, which just means, you know, that was the exclamation point, means factorials, so just multiply by numbers times each other. I'll just show you. So this one, because 2 is down here, that means we're starting with 2. So we're not going to have a first term. We're just going to start with n equals 2. So we'll get 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial. I want to actually evaluate this. The point is we're going to go from 2 to 5. And then each one of these numbers, like 4 factorial, is 4 times 3 times 2 times 1, just to remind you. If you're not familiar with that, search for it on this site. All right, so how to tell geometric from arithmetic. The key thing is no exponents in your arithmetic. So because we have 7 times k, that's going to give us an arithmetic sequence. And that means we can use our arithmetic formula on it. So if I'm finding the sum of an arithmetic sequence, then all I have to do is look for the formula. And the formula for this one is going to be that the s of n terms of an arithmetic sequence equals n over 2 times a1 plus an. And that's all there is to it. So in this case, I'm finding the sum of 16 terms, 1 through 16. 16 over 2. Now a1 and an, I don't actually have those, do I? Oh wait, yes I do, because this right here is actually the explicit formula for each term. So I just know that my first term is what I'll get when I plug in 1 for k. So it's 7 times 1 is 7 plus 2 is 9. And then my a sub n, my last term, which in this case is the 16th term, that's what I'm going to get when I plug in my last number, which is 16. So plug in 16, and 7 times 16 is what? 7 times 16. Oops. Holy crap. 7 times 16 is 112, plus 2 is 114. So just plug that through my calculator, and I'll get the answer. Geometric. Now, because I have an exponent of n, that means that this is geometric. And I could also spot this by listing off a few terms. So if I just list off my first few terms, plug in 1 for n, I'll get 3 times 2 to the first. My second term will be 3 times 2 squared. My third term will be 3 times 2 to the third. So 3 times 2 is 6. 3 times 4 is 12. This one's 24. So you can see I'm doubling. I'm doubling to 12. I'll multiply by 2 to 24. So that means my r equals 2. And once again, not a coincidence that 2 is a thing being raised to an exponent. But what that means is I can just use my sum equation for geometric formulas, geometric sequences, which is s sub n equals t sub 1 times 1 minus r to the n over 1 minus r. Now I'm not going to go through this again, but check it out. This is once again the explicit formula. Whatever's behind the sigma sign, all this stuff is the explicit formula for the terms. So since I need my first term, all I do is plug in 1 to this to get my first term, which I already did just a second ago to show you it's geometric. So I just have to plug in a 6 right there, and then my r is going to be whatever's raised to the exponent. So in this case it was 2. Or if you're not comfortable with that, you could always just list off a few terms like I did. You'll see that we're doubling. So that means I just got to plug in my r equals 2 right there for r, and it'll just plug and chug and get the answer. It's probably a pretty good sized number in the hundreds of thousands. Alright, so sum of an infinite geometric series. Now we said in the previous video about geometric series, we can find the sum of an infinite series. The real key is that r is less than 1. So why is this one going to fail? This is a geometric series, but it's got an r of 2 because we got 2 to the power of n. That's no good. These terms are going to get bigger and bigger and bigger, so there is no sum. Or the sum is infinity would be one way of looking at it, although that's no sum is like almost certainly what your teacher wants you to write. It's more mathy and official to write no sum. And then this one is actually going to work out because I've got an r of 1/2. So all I got to do is use my infinite sum formula here. Now what's t sub 1? All I have to do is plug in the first number, which in this case is 1, and I'll get t sub 1 equals 3 times 1/2 to the 1, which is just 3/2. So t sub 1 equals, so my infinite sum of infinity terms, because I have an infinity up here, which means infinite series, is going to equal t sub 1, which is 3/2, divided by 1 minus r, 1 minus 1/2, which is 1/2. 2's will cancel and we get 3. So not too bad, right? Sum of an infinite series. So as you can see, this sigma notation is really just a fancy mathy way of asking you a sequence problem and asking you to add up the terms. So whether it's a short number of terms and you can just add them up manually, maybe even if it's not a geometric or arithmetic sequence, but it's pretty short, you can just add them up manually by plugging and chugging and adding everything up. Or if it's a longer term or even an infinite one, just use the relevant formulas from your formula sheet for sequences and series, and just take that somewhat fancy problem and plug it into the formulas you already know how to use, and that's how you get your answer. The key though is if you've got an exponent, n or k is an exponent, that's a geometric series, and if it's out front, that's going to, and no exponents at all, that's going to be an arithmetic.